We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
So now here we are getting S is known as a syndrome, which is a variable to store some values which can be obtained by multiplying EI into HT, which can be obtained by multiplying EI into HT, where EI is the vector and HT is a matrix. Now this portion we elaborate further. So here if I say the error vector E is simple known as E1, E2 up to some value of En. Let's say n is equal to 6 for simplicity purpose. So we can take here the E is 6. And HT matrix is known, so I randomly choose here the HT matrix is nothing else but it just show a 1 1 0. This is a parity part, 0 1 1. This is the parity portion, and there would be identity matrix, so 1 0 0 0 1 0 and 0 0 1. So we can form like this way. Now the syndrome S is obtained as EI into HT, right? This can be obtained of EI into HT. So we have to identify, the main objective over here is to identify the error E. So if we say this is E1, E2 up to E6, and if the same HT has been placed over here 1 1 0 1 0 1 0 1 1, then identity matrix I is 1 0 0 0 1 0 and then 0 0 1 if it is matrix like this. So we need to solve this, but the problem here is this is known only because it is stored at receiver, so this is known, but this is unknown, and even at the similar time this is also unknown. So what we can do here, we go with a trial and error method, or we will try to solve this equation with the way in which we are totally unaware about the syndrome value S and error vector E. This matrix is simple 3 row. There are how many rows are there? 6 row, and there would be a 3 column. So this matrix is simply known as a 6 comma 3. This matrix is simple known as a 1 cross 6. So this is 6 and 6 over here. So this matrix S is simple known as a 1 cross 3. The size of S is simply 1 cross 3. So S is simple defined as a 3-bit information, S1, S2 and S3. 1 row and 3 columns. So this is 1 column. So we can obtain here that is S is represented as S1, S2 and S3. And that is nothing else but that is equivalent to E1, E2 up to E6, that is this HT matrix 1 1 0 1 0 1 0 1 1 1 0 0 0 1 0, and here there would be a 0 0. Right. Now we apply different combination of this one. So first we choose they have 8 combinations are there, 8 possible combination. How many possible combinations? So you can say the S and you place S, so S may be a 0 0 0 up to a 1 1 1. So if you put any one value here, any one value you can put, let's say 0 0 1 you place first. and you solve this equation for this 0 0 1. So if my syndrome is this one 0 0 1, so what would be the value of this matrix E, right? So you replace this with this value 0 0 1 here, 0 0 1, and we try to solve this. So then this cannot be, it's very extensive process, because we need to apply all these combinations, and this is not possible to solve manually, but by using some computer simulation like as a MATLAB and other software, we can solve this. And if you solve this, so we can say this equation will be satisfied if the vector E is 1 0 0 0 1 0 0. So that is E1 and that is E6, and there are all other bits are there. So if you put this one, this equation can be rightly satisfied. So if you solve this one, that you can say this is 1 0 0 0 0 0, you can satisfy, right? So this value 1 0 0 0 is not only the single value for which this equation can be satisfied, then you are getting some other value, like as this equation can even be satisfied with 0 1 1 0 0 0. Then you find there are 6 combinations you will find here, so maybe possible that would be 1 1 1 0 0 1. So all this 6 combination of error vector, this equation can be satisfied. Right. So if you put the syndrome as a 0 0 1, so you are getting 6 combination. So you are getting a 6 combination here for this 0 0 1. You are getting a 6 combination of E, where this would be the right, like as a 1 0 0 0 0 0 is right, 0 1 1 0 0 0 would be right, then 1 1 1 0 0 1 would be right. So there are 6 combinations you can place. This is error vector S, and this is for the syndrome. Now out of this one, you have to choose any single one, because your answer would be a single one. So this can go with this can go with this can go with this, in all, for all error combination, and for this syndrome, this equation can be satisfied. This can be satisfied with all these values, right? So here we are getting the multiple value of error vector. If we ended with a single value of error vector, then work becomes very simple, because that error vector we have identified by this way, and this error vector we can use to get the code vector by XORing error vector E with R, or R with E, and then we are getting code vector directly. So here we can identify the error vector, but the problem is there are multiple values can be found. So with which value we'll go? So we'll apply the maximum likelihood algorithm. In the maximum likelihood, we can have to say that the code vector C and R, we will choose the combination for which C and R maximum closer with each other, or C is maximum like with R. So this algorithm is known as a maximum likelihood. So we will find the probability with all this combination, and for which we have a minimum Hamming distance between C and R we will choose. So minimum Hamming distance simply means R is actually obtained with C and XORing with R. So if E would be 0, then R and C would be same. But if E have a 1 bit, then R would be differed with C with 1 bit. If E have a 2 bits have error, so R will be differed with C with a 2 bit, so forth. So the distance between R and C can be increased with E, error vectors. So if error vector has a more number of ones, means more error, that is simply known as a more error, then is proportionally to this, the distance between R and C would be increased, right? So basic is this. If we will go with a maximum likelihood algorithm, we will choose the error vector which make the minimum distance between code vector C and R, and so that is the minimum error. So if there are so many combinations are available which can satisfy this equation, we will choose the error vector which create a minimum distance between vector R and C, and that is the minimum number of errors should be there in error vector, and that is the first one, because here in this you can say there are only single bit error, first bit error. Here there are 2-bit error, this is single bit error, this is a 3-bit error, 4-bit error, and so we will discard all this. This all is discarded, and this one is selected. So this is a way how we can select this whole the things. So basically what we learn here, we will take a one syndrome, we will choose a one syndrome, and for one syndrome we try to satisfy this equation. So we are getting a multiple possibility of error. Out of this error possibility, we will go with a maximum likelihood algorithm. So we will choose the error vector which has a minimum number of weight of 1, and that will be chosen, and this is enter in this table here. So we can choose any combination 0 0 0, and for this one we have choose the error vector E. Now in the same equation here, now we will change the value of S from 0 0 0 to 1 0 1, and for 1 0 1 we again do the similar process. So find all the possible combination of error vector E, and out of this error vector E we will choose the error vector which has a minimum a number of error, or which has a minimum weight of 1. That E would be a 1 0 0 0 0. Same, we change the syndrome with 0 1 1 and find the error vector. So in this way we will find a pair of S and E, syndrome S and error vector E. So we have 8 such combinations are done. Once this is done, then it means, so if we can find the syndrome S, then we have a table is available, and this table is stored in the memory of a receiver. This table is stored in the memory of receiver, and from this first we have to identify the syndrome. And how we got the syndrome? So syndrome is simple. Whatever the receive vector R is available, we store with HT matrix, which is stored in a receiver. Then we find the syndrome. From this syndrome, this one is already pre-calculated, and this pre-calculated table is already stored in receiver. So we look back to the table for whatever the value of S we have obtained in here. This value S, we will find the particular entry of syndrome. So if this is what would be a syndrome, that we will find the error with responding to this one. So it's 0 1 0 0 0, and this error is finally we will consider as actual error between transmitter and receiver propagation, and this error is finally added with or XORing with our receive vector here, and then we will get the code vector C. So this is the whole procedure. Now let's summarize the thing. So this part we have learned so far. If multiple error vector is found which produces same syndrome, the error vector with a minimum weight, minimum number of ones is chosen. So we will see here probability of receive vector R when Ci is given. It should be larger than probability of R when Ck is given. So we go with this one because it has a largest probability to match R with Ci, right? And for this one, the particular error vector is chosen which provide the minimum weight. So we can have this table. This table is pre-calculated. So we are not before the actual system is to be start or actual system becomes active. This table is already pre-calculated for a different value of syndrome and different value of error combination, and this value is to be stored at the receiver. And this is very helpful. This table is known as a decoding table, and this is very helpful to identify the error. Right. So best pair combination of syndrome and error are placed there. So now we summarize the general procedure. So first, whatever the vector is received, that is R, that is known because we are receiving this. HT is also known because it is already stored in the memory. So we multiply the receive vector R with already stored vector HT, then R into HT, we are getting the syndrome S. Now we refer the decoding table here, and whatever the we will find the best match of syndrome S with the error E. So we will look back to this row. S is matched with which error vector. So from this table, referring the decoding table, here we will find the syndrome. Here we will find the syndrome. And using this decoding table, we will find the error vector E. So here we will find error vector E corresponding to the syndrome what we have obtained here. So in the next step, once we have done this, so in step number 3 we have now get back with the error vector E. This error vector E is XORing with the receive vector R that we have already shown. If we are doing this operation XORing R with E, and then we are getting the code vector C. So we are directly getting the code vector C. So step number 3 will give us a code vector C, and this code vector C is itself a first k bits of code vector C are identical to the data vector D. So we can extract this one, and then we are getting the data vector D. So this is a procedure. So it is very simple procedure, and using this procedure we are able to get the data vector D. So now there is one example. In this example we try to see how this all things can be worked together. So there is a linear combination of 6-3 code, and within this 6-3 code, let us assume the matrix G is given. So matrix G is given like this way. The first part is identity matrix, the remaining part is known as a parity matrix. The receive vector is given as a 1 0 0 1 1, and for this receive vector we it has been asked to find the corresponding data vector and using the maximum likelihood detection algorithm. So the question is reverse here. In this question, receive vector is given and matrix G is given, and from this matrix G and receive vector R we need to identify the data vector D. So first part is we have to find the code vector C. How we can find the code vector C? So we have to find the error vector. If you see everything in a reverse order, so we need E. How you find the E? So we need to find first a syndrome, because from a table of decoding table we find the error vector corresponding to the syndrome. And how we will get the syndrome S? So we need to multiply R with HT. That will give us a syndrome. But where is HT? HT is not available. We have only G. So in G, this is a parity matrix. We can construct the HT. This part is the parity matrix. This part is the identity matrix. So this parity matrix is 1 0 1 0 1 1 1 1 0. This all are copy over here, and the remaining part is formed as identity matrix. This is HT. So HT can be constructed from G. Then we multiply R with HT. So receive vector is 1 0 0 1 1, which is provided to us. Multiply with the HT matrix. This is HT matrix. This is R. Then we do the similar process. The first one will go with a first, then the 0 will go with the second element, then the third elements of R will go with the third bit of H. So this is first, second and third. We will do this XORing operation. So 1 into 1 here, then the second bit of R would be 0. First column, the second bit would be 0, 0 into 0. Then this is the third 0 with 1. Then we are getting 0 into 1. Then fourth bit of R, 1 with this one, 0 1. Then 1 with this 0. 1 with this 0. This one would be this 0. Then now this will give us a first bit of syndrome S1. Then we are getting the second bit of syndrome by multiplying all the bits of receive vector R with the second column of HT matrix. So this one will go with this 0, 1 into 0, then this 0 will go multiply with 1, and so forth. You are getting S2, and you are getting S3. If you simplify this, all 1 into 1 1, 0 into 0 and 0 and all. And if you are XORing this, so first is 1. This is our S1, this is our S2, and this is our S3. So we got the syndrome S. So what the procedure we apply? We have a G. From G we have constructed HT. Basically it is stored already in receiver, so HT is available. We multiply R with HT and got the syndrome value. This S is 110. Now we look back to the table which is available with us. So we will go to the table, and from this table we will try to locate the syndrome. What is the syndrome? 110. Remember this 110. We try to locate on this table. So here this is 110. You can see this one. This is 110. This one. And what is the error for particular 110? Is 001000. So error is identified. This error is identified as a 001000. It means the first bit has no error, the second bit has no error, there is a third bit, first bit, there is a second bit, there is a third bit, there is a fourth bit, and there is a 5th bit, there is a 6th bit. It means only the 3rd bit is an error of a code word. So now we will XORing this R with E. So R is available 100011, XORing with this E 00100. We have found this from lookup table. We XORing this operation and finally got the error vector E 101011. So this is known as code word C. This C is written here as a 101011. It's a 6,3 code. So first few bits, K are 3 and is 6. So this 3 bit is your data vector 101. Right? And this is applicable for the assumption of 1 bit error only. If there are 2 bits and more bits error, so this lookup table will not work. And if this lookup table will not work, then definitely this lookup table will not work. This work only for a single bit error. If it doesn't work there, then we are not getting the right error vector, and if right error vector is not available, then we are not able to get the right code vector C, and then all the processor will fail. You take a note of this. So now this is a one part that we need to understand, and we will conclude this lecture with some advantage and disadvantage of a linear block code. This is the encoding and decoding process of linear block code. So what are the merits of linear block code? So the merit is the simple design of encoder and decoder. But what is the demerit here? Here we have to wait for k number of datas. Demerits, if you see the demerits, so we have to wait for a k number of block of data is to be collected, and once it is collected, then we process. So we cannot process the running basis. And when we learn the convolution code, we will see the data is to be convoluted on running basis. But the another advantage of this is that code efficiency is comparatively higher. If you see another codes like a convoluted code and all, we will see code efficiency goes down. Here code efficiency is good, but the demerits over here is that transmitter has to wait for k bits to be collected. So that is time consuming, and so delay is higher. Okay, so this is all the processors. So now we would like to